Hey guys, welcome back to The Mess, and I'm your host today, Eddie the Grouch. Welcome back to The Mess. I'm your good old buddy, Uncle Grouchy, and I wanted to just flub up my line. Wait for the plane to go by. Hey, it's your old pal, Uncle Grouchy, and today I'm going to do a video that's probably been a little bit overdue. This is kind of an introduction and just show you a few things around here so you get an idea of where I'm coming from and probably where I'm going to wind up. But a couple people have been asking me, you know, what kind of machine I'm running, and that's a bad introduction. Hey guys, Joe Pal, Uncle Grouchy, and this is going to be kind of my long overdue introductory here I am video, and kind of tell you what the channel is kind of about. Well, when I started out, the channel was supposed to be about overall tinkering. Duct tape, baling wire, get it done by the seat of your pants underneath a moonlight on a holiday because you can't get to a store and get whatever you need. But somehow, right after I started doing this, those things kind of dried up. But anyway, people were kind of curious about, since I've gotten more into the machining thing, it started with a midlife crisis. I was really depressed watching a lot of YouTube because even I couldn't get depressed enough to watch daytime television. So going through YouTube, I somehow got onto some machining channels, and it just became hypnotic, relaxing. The first one was Keith Fenner, the Fenner, and just watching him put together something so effortlessly, and it was just hypnotizing. So I figured, what the hell? Rather than do drugs, women, and fast cars, I hit Craigslist and was looking around for machine tools. And despite the warnings, which I did read about, I got a Smithy. Yeah, I'm paying for some really bad things I did in a previous life, but that's what I got. Since I've gotten that, the adage of, if all you have is a hammer, every problem becomes a nail, that's kind of what happened here. I've been incorporating that stupid thing that I've spent a lot of time and effort getting it to work, you know, into just about every project. So the channel kind of shifted to machining, and which is really bad because, well, I'm really bad at it. I've been playing with this for a couple of years now, and I guess it just felt really good not to be using baling wire and duct tape and all that stuff. You know, being able to actually have tapped holes and things that are kind of square instead of chopped up with an angle grinder. It's been kind of cool. So that's why the channel has been kind of heavy on that stuff. But I'm really going to try to branch out, just get back to the other stuff I used to be good at. But anyway, I get a lot of questions about the machine I have, and I thought I would kind of give you a walk around with it today. Well, actually, the question I usually hear is, you know, what's a 2-bit bald-headed, chain-smoking inbreed streak of piss posting videos on YouTube anyway? And I'm like, Mom, just leave me alone already. You know how parents are. They have a high expectation of the kids, and when it turns out that I didn't get the position as the head maitre d' at IHOP, I kind of fell in with a bad crowd. So, without further yapping, I'm going to swing you around and we're going to look at the piece of shit. Here we have, in all its nauseating glory, a vintage Smithy CB-1220. This is a 3-in-1 machine. It's also known over the pond as a Clark CL500M. This machine here, I think, was built around the 1800s, and I also think it was a copy of a Russian design from the 1700s. But either way, these are put together in grass huts all over China, and it has a lot of drawbacks. I don't even know where to start. Anyway, I guess we'll start at this end. It's a tabletop unit, but I guess it's considered a benchtop or a tabletop machine. And it's a little bigger than the X2s and such that Harbor Freight, I think, still sells. But I don't even know who the parent company is. It's manufactured for Smithy and Clark. Why they chose to latch onto this particular piece of junk, I just don't know. But I have my hand here on the tailstock, and somebody was asking about this. And the original travel on this particular unit was about 1.5 inches, 1.75 inches. So if you're trying to get over this table to do some drilling, well, you had to get up real close. And that was about all the travel you got, and then the screw would disengage. It wasn't very good, and it was pretty damn irritating. So one of the first things I did after getting the machine was to do a stretch limo job on the tailstock. And that involved cutting off the tail end, this little piece here, which houses the plain bearing that, or the bushing that the screw rides in. Cut that off, and I put in 2 pieces of aluminum. Yes, that's 2 pieces, because at the time, this was about the longest boring bar I had, so I could only bore out 1 piece at a time. And that was just sandwiched together. There's no glue or anything, just squished together. And 4 holes were drilled in the back of the cap, recessed, and then 4 long motor screws, like a fan motor or something, about 2 or 3 inches long. And I've got 4 of those just shooting right through and clamping the whole thing together. The barrel itself was extended. Yeah. Should have had this ready to go. I still kept the original screw pitch, because, not knowing what I needed, I imagine that would give me the most thrust for drilling into something heavy. There we go. So that's about my current travel now, and that's about 3 times what I used to have. The barrel was cut off the back. No, it was machined with a pocket, and then this blank piece here was bored out with a matching tab or stub that slid into the pocket, and then the whole thing was silver soldered or brazed together. But before I did that, there was a threaded insert in there, and I was able to pop the insert out and press it in to the back end of this one. This little gray piece here is just a piece of PVC pipe that I was using to limit the amount this thing retracted, because I wasn't paying attention, and I made the extension a little shorter than I really could have put in there. So that just keeps it from drawing so far into the housing that it would disappear. Also, I was planning on putting an indicator, something on here that I can attach an indicator to, and if it came back all the way and inside the housing would pop off or and smash against whatever I had on there. So I just had it so it would limit the travel here. The screw itself is just a new screw that was made up a little bit longer, but keeping in mind the end of the screw is still at about the right position to pop out any tapered pieces I have in there. And I have it sized for mine. I usually cut the tangs off my tapers, because when I put them in the mill, I want to use the drawbar to hold them in. So this way, it's about the right size, and everything works out just peachy. And that was a pretty simple mod, because back here, this does not have to be bored precisely. It just has to be bigger than the shaft, because all your clamping and holding power is in this section here, utilizing this cotter bolt arrangement on the handle, and it would squeeze the tapered bolt up against the shaft. And it is a silly mechanism, and I believe I'm going to change that to an idea I saw from another YouTuber, and I'm going to post a link to that particular video that gives a lot of ideas for me to further improve this already wretched device. The bottom of the barrel is grooved all the way to the back with a keyway, and there's a small key with a little tit of round metal that slides into a round hole inside the casing here, and that keeps the spindle or the quill from spinning around. And so that keyway was just extended all the way to the back through the new piece. And the key in here was upgraded to something a little bit wider and beefier, because I still am abusing the snout of this machine. I didn't want that breaking and spinning around. And that was pretty easy to do, because there was a lot of slop in the hole, so I could still make a bigger one and still fit in the hole. That's how badly these things are made. Anyway, that was definitely a well worth it type of mod, because that extra travel has really come in handy. It's just this. There's really no way you can peck. And like I said, that link I'm going to show you, a nice fellow from Germany that made a rack and pinion style quill that he can just bring that thing back and forth all he wants. And I'm probably going to do that with this machine sometime in the near future. But that's all that modification was. A stretch limo job with extending the barrel of the casing and extending the quill and extending or making another screw. Anyway, the next shortcoming on this machine is there's no half nuts, and so there's no way to disengage the table from the lead screw. That makes threading a real pain in the ass. So outside of having to change the gears, you need to stop the thing, work it right back in reverse, kick it back in, go forward, you know, the old school type of threading. And that was kind of the reason why I went to this half-assed CNC setup I've got on there. I put stepper motors on all the axes. And that was because of the threading, basically. I did not have the change gears with the machine, and if I could find them and paying the Smithy prices, if they had them, it was just worth it to me to pay a little bit more and kill two birds. So now I can do any thread pitch I want, and the table is all controlled by the computer, and I don't have to disengage, run it backwards, blah, 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 blah. The gibs are all thin. They're some kind of nasty, twisty cheese metal. So another upgrade would be to machine out some thicker gibs and lap or scrape them up and put them inside there. So that's going to be in the future, because that's an idea I got from the video, from the link I just posted a little bit ago. The gib for this particular setup here runs right across the table, and you can see for such a long table that is a narrow footprint. It's like a narrow wheelbase car that when you take a turn it's just going to roll right over, because you've got all this weight back here, and I may have a mill vise back here sitting there just adding more weight, but actually sometimes it helps dampen down chatter and vibration. But either way, with this mass here, and you have your lead screw up here only pushing on the side of it, it wants to cock a lot. So you'll crank this, the table cocks a little bit, and it wears this side of the gib. And then you come back, and it starts wearing this side of the gib, because there's no wide base to spread the load. Like on a better designed lathe, you'll notice that the tables have these long outriggers. And that's a nice wide footprint that helps even the wear, because the bigger the wear surface, the longer it's going to take to actually create wear. It's more stable, it's less chatter, and it's just more accurate and a better design. But because it's so narrow, it's problematic. You're always having to adjust the gibs, and as badly as this thing's machined, you're going to have tight spots and loose spots, so you have to adjust them for the tightest spot you have. And then when it goes to a loose spot, well, you just have a loose table. So if you get one of these, you're going to want to take up scraping or machine rebuilding. And I'm learning a lot playing with this stupid machine. So my next effort's going to be getting some scraping materials together, learning how to do it, and scraping in this cross slide, the saddle, and all that wonderful stuff. Another problem, these lead screws suck ass. These are metric. This one's, I think, a 20 millimeter by 2 millimeter pitch. And the one inside the saddle is a 16 millimeter by 2 millimeter pitch. And that's not so bad in itself, except there's a lot of cranking going on, because, like I said, there's no way to disengage from the screws. But these are made very poorly. It's not linear travel throughout its length, so it'll have some bunchy spots in here where it'll narrow down and widen up. You can't see it, but you can tell when you're machining, because your measurements are off on different points of the thread. Also, there's nothing concentric about them. You're going to have the thread, we'll say we center the shaft by the threads. You do that, you spin it, and you'll notice that the end machining is all nice and wonky. So your handle's jumping up and down, and it's just crappy. Also, the ones I had on here and the ones I got as replacement had some kind of plating or something on the thread portion, and that flakes off and destroys the brass nuts. And I'm on my second set of brass nuts now. Let's not go there. I'm on my second set of nuts, and they're already wearing out to the point where these are going to need replacing again. And one of the next upgrades or changes going to be is I'm working on some Delrin style nuts, and that's going to be a whole nother series when I come up with an easy way to make these that doesn't involve buying a tap that I'm just not going to do. I'm not going to spend $150 for a tap. I'm not going to use that much. Plus, I'm going to have to get 2 of them. So, no. So I'm working on a way to work on these, and I am familiar with, if you guys read the forums, I believe it's Practical Machinist or maybe Home Machinist forums, where one of the posters, Evan, we call it the Evan nut, come up with a way of making 2 halves of Delrin, heating up your existing screw, and then clamping it down, and it will melt into the threads and ooze out to the sides and make this essentially one homogeneous piece. But Delrin has a high thermal expansion factor. So once it cools, you're playing hell getting it off the screw, no matter what you use for release agent or grease. It's just wrenched on there tight. And you have to do a lot of working back and forth or playing and sanding and dorking with it to get these just to move freely on the screw. And another thing that was, I don't believe is taken in consideration with making these is, not only does it clamp around the diameter, it also shrinks lengthwise, so then the threads are acting like it's a different pitch. So they're clamped against the sides of the threads. So I'm working on a method that would that a home person can make these pretty fairly simply, that someone can make these with a little less headache, and I'm working on that, and I said that's going to be another series. So lead screws suck, the tailstock travel sucks, the common bed sucks because you can't have the wide outriggers to hold the table and have your tailstock slide in between those legs to get up close because of the common bed design. This is a 55-degree V-bed, and it collects a lot of snot. The screw is unprotected, so that collects a lot of snot. I have yet to get one of those concentric spiral springy jobbies, but that's going to be on my list. But if I'm careful, I just blow it off. I've been using this for now, just a piece of canvasy, rubber-coated cloth that is just attached to the table, and that keeps the gunk from getting underneath the table because it is a gap here, and it keeps chips from getting blown and sucked up in there, and just for the couple months I've been using that, it's worked out pretty handy. It just looks really stupid, and if you attach it here, it just bunches up, so I have to pretty much keep that loose so I can fold it over to reach whatever area on the bed I am. Other shortcomings. The mill head. The mill head has an issue with, the only way you can lock it down is with this handle, so the first thing you're going to need to do is lengthen that handle so you can get more torque on the mill head to keep it from spinning around that post when you're doing any kind of machining anything other than foam, because it gets kind of loose. So that was a shortcoming, and I addressed that with this mechanism, and I'll get back to that in a minute. The other thing is the head is so short. By the time you removed everything off the lathe, you only get about 5.5 inches of travel of usable mill space before you're going to bounce off the spindle, and that doesn't give you a whole lot. It really doesn't. So you're trying to do everything sideways on the x-axis or whatever it is for mill. God, that pisses me off. Changing the letters around for a different milling operation, it just drives me bananas. So you pretty much have to pick one setting to keep in your mind, and then do the mental conversion of the axis letters with the DRO when you're moving things around. It's a kludgy mess. But anyway, you have a very short spacer, so you're trying to work this way as you would with a normal column style mill. But when you're doing that, you've got the side twisty pressure there, which overcomes this friction, and then your mill head's moving all over, and you're screwing up your work. Another thing is the height. The height was adjusted for the mill head by a collar that rode underneath the casing here, the casting. And the collar had ball bearings integral to it, and it rode up on these rounded grooves into the post, much like a power steering or a manual steering box. It wasn't recirculating balls, but they did do the job. And to raise it, you had to have a couple handles in this collar and swing it around. Well, the handles would be like this far from the mill head, So if you had any kind of fly cut or something there, you're bouncing off of that. So you'd have to unscrew a handle, put it over here, swing it, move the handle, swing it. Huge, huge pain in the ass. So that's why I put this little motor advanced here. Let me change the camera around and show that a little bit better. So up here is a window motor, and that was sort of half-ass mounted on this doohickey chunk of metal here that's screwed into the top post of the adjuster mechanism, which rides here, and I can't use because I can't find the original size belt that fits this. So the next closest that works is already tight, so I don't need to use the tensioner, which is good because the thing exploded when I tried running it at high speed. So that's out of the way. But anyway, there's this post up here that not only holds this adjuster, but acts as the hold down for the plastic cover that sits across the mill head. I'm not big on covers, so that went, and I screwed this block of aluminum on top of that, and that is offset just to be a convenient mounting place for this window motor. That is attached to a little shaft here that can be, so the whole unit can be removed for servicing or getting it out of the way. And that is attached to a new lead screw, which is just some threaded rod. And that goes through this bearing block, and inside of here is a skateboard bearing. So it's sandwiched in between these two pieces of aluminum. And this aluminum here is screwed down or bolted into the housing with very small screws, because I'm afraid of taking much metal out of these cheap castings is going to weaken it. But so far I haven't broken anything, so that's working out good. And this is just, I believe, 3 number 8 screws, one on either side of the post and one in the back. Sufficient enough to lift the head. And the lead screw goes down through to about, somewhere in this area. And this is a piece of EMT, electrical conduit, the thin shit. That's a piece of half-inch conduit, and in the top of that is a threaded plug or a nut that's welded in place to engage the threads of that screw, and that's just held down here at the post. There's a post that comes up off this little mounting thingy. It sits over that, and the screw's holding that together. What does that do? This is a great mod. Hey, these are just ideas. They're not good ideas, maybe, but they're ideas. So I want to spark some fun with this. I have very little room in my shop. Anyway, back to the head. So I replaced that lifting collar with more of a stationary collar. This was a piece of cast iron lifting weights, exercise weights, and that was machined and bored and split in the front and the back. And it has one stationary bolt which holds this section together, and on the back side I have this lever here which tightens this side, and that clamps the whole mess together. This stays in the bottom portion of the post and acts as an anchor. And it does 2 things, really. It provides the anchor point for the lifting mechanism. So I can just raise this up like this, and when I got the spot I want, I can clamp down, and that's groovy. But not only does it provide the lifting, I attached it in the back. Maybe I should swing it this way. Get my wires there. In the back here I have this sturdy steel post here, which is bolted onto the base, and that goes through a close-fitting guide. It's just a square guide, and it's pretty tight on there. It doesn't move. So when I lock down the base, that gives me extra holding power on the mill head. So this clamps to the column, transmits its anchoring through this block to the mill head, and then that together with this lever back here gets me, it multiplies the holding force of the column. So once I've got these both locked down, it doesn't work. Or, excuse me, it doesn't move. And the third thing this also provides is it holds the position. So with that collar, to lift the head, you had to release your hold down here, and you spun that collar around. Well, you lost your position. So if you were doing anything accurate with the mill, you had to get it up to your new level and then dial in where it was and then lock it down again. Well, with this, I can just keep the bottom base locked and then raise and lower, and I do not lose position, because this won't move unless I really whack on it, and you're just repositioning. And that's really handy for when you need to drill something a little bit longer than the travel of the quill. The travel of the quill is about 3.5 inches, I believe. Let's see. Now we got the indicator there. Okay, where are we now? That's I'll put that off. Oops, excuse me. 0. We're on inch. Yeah, 3.6 inches. Or a little over 91 millimeters for you other guys. Which is, I guess, okay in and of itself. It's not bad. I've seen some machines on YouTube that only have like a 2-inch travel, so that is kind of generous. But as I said, when you're trying to drill something deeper or bore a little bit deeper, well, you go so far, and now you're extended way out here on the quill, and that's not good most of the time, because now you're losing some support. So it's nice to be able to go down so far and then drop your mill head and continue drilling. Or you can use a stubby drill to start, go so far, and then lift up, move your stuff around, put a bigger bit in the hole, bring your table back down, put it together, and, well, you know how to work around that stuff. But it gives you a lot more possibilities. So being able to keep the position is a wonderful feature. Being able to lift it other than playing with that stupid collar is a wonderful feature. And the extra clamping. So this has been a really worthwhile addition to this machine. What else did I do to it? This whole mechanism in here is sloppy as shit. And there's not a whole lot you can do about it. The quill is like a drill press quill, which is basically what this thing is, the glorified drill press. And the problem is, when you are either using the regular hand feed, or if you're in the fine-tune mode, you still have the slop of the rack and the pinion gear in there. So you can still, that's how much slop you're going to have still playing with your machining. So you pretty much have to get your height, lock down your quill, do a little bit, and so doing any kind of contour milling becomes a crapshoot because of that slop. And inside of here, there's not a whole lot you can do with it, really. It's got this dog gear clutch that engages or disengages the fine feed. So that's a big spring-loaded snotty mess in there. You've got the worm gear and the worm that doesn't mesh really well. The standard fine feed knob, it's kind of that long, and there was no support up front, so just working that would wear out the bushing in here, introducing more slop. So when I put the stepper motor and its associated mess on the front here, I was able to extend my fine feed for manual and put a bearing block up here, just a plain hole through some aluminum, and it's so much sturdier than it was. But if I want any kind of accuracy, I just ignore the whole mechanical mess altogether and use the CNC motor, because that has a direct drive to the screw here, which goes into this piece of square tubing, and on the top here I have welded in a matching nut for the screw I'm using. And this is long for the reason of, if I'm using this manually, I don't have to worry about coming back up and locking back into the nut. It's just all here, and it'll stay within the post, and no matter where, I can always lock it down if I want to, or not, since I usually lock it up at the top. But it just keeps me from having to remate the two pieces and worrying about them staying in alignment, because after all, this thing spins, so if I happen to spin this, it would get cocked and it wouldn't go back in the tube. So by having that inner tube that follows the length of the outer tube, they stay all together. And along with that, with these two pieces here, that keeps the spindle nose, or, yeah, the spindle column from twisting back and forth also, because now I can attach stuff on the front of this base plate. Here's one. This is a plate I made for putting a rotozip tool in there, and I can use that for a high-speed spindle to machine foam or plastics. So that does a couple of things. It lets me put a high-speed spindle on, and allows it to be offset from the original spindle. So now that it's out here, I get so much more table travel because I'm not bumping up against the spindle all the time for the lathe. And that's just pretty easy. It bolts on the front and the bottom, and that holds it pretty darn steady. So to keep that positional accuracy and keep this column barrel from twisting, that's what these two plates here do. That keeps this tube registered so that plate doesn't swivel around. And it needs a little bit of adjustment, but so far it works pretty good. And the locking lever was extended out with a nice beefy shaft, so that's not in the way. What else is there? Now the knobbies here are manual pulse generators. They're just, I believe these are 100 pulses per revolution. And I just grabbed those off eBay, and I have that incorporated into Mach 3, which does my manual motion when I have the motors engaged. So I can get really precise with this, and that takes care of the shortcomings of the mill head accuracy as far as I could do now. And that was worthwhile, but the whole CNC thing, I'll just make that a separate segment if we want to get in depth with that. And I'll be glad to help anybody who's considering stuff like this, or look what I've done and see. It does work. It's ugly. Like I said, they may not be good ideas, but they are ideas.